solve the system of equations by graphing, draw each line, and yeah. All right, so we're supposed to graph both these lines is the deal on this question. So I'm going to grab the first one. I'll bring it over here. This is y equals, my first one is y equals 2x plus 2. So you remember how graphing works, right? That when y is alone, remember it's y equals mx plus b. So that number out there is the vertical y-intercept, right? That's our starting point. So right here at up to right there. Okay, and then the number next to the x, put that over 1. That's your slope. That's your rise over your run, right? So if you have a whole number next to x, put it over 1 so that it looks like a fraction. It's rise over run. So that means we go up to 1, 2, up to, that's the rise. And the run is over 1. There we go. There's the second dot. Now we can connect those dots. And form our line. There we go. How are we doing? Is that good so far? Everybody seeing what we're doing? So let's recap on that real quick. So y is already alone. When y is already alone, it's just y equals mx plus b. You start out with the b, the number on the outside. That's your vertical y-intercept. So that's your first dot right there. And then from there, you do the fraction that's in front of x. If it's not a fraction, put it over 1, make it look like a fraction because you haven't changed anything. 2 divided by 1 is still just 2. It just looks different now. I call that plastic surgery. We do that all the time in math. We remove the wrinkles, make it look different. So it's still the same value though. Still the same person. That's 2 over 1, which is still just 2. Haven't changed the value. It just looks different. 2 over 1. Now we have 2 numbers for rise over run, or slope. So that we go up 2 over 1, connect the 2 dots. There's the first line. Now the other line we can, right here, it's just x equals 1. Remember when we have only one letter, if we have only x or only y, it's just going to be a horizontal or vertical line straight through that axis at that number. So x equals 1. So this is the x-axis, this is the y-axis. It's going to go straight through right here at x equals 1. Does that make sense? So when you have only one letter, it's easy to graph them. The line just goes straight through. It's going to be a horizontal or vertical line going straight through that axis at that number. So at x equals 1, it'll go right through the x-axis, straight through the x-axis at x equals 1. So you just put any 2 dots. I can put a dot here and here. It doesn't really matter. Put any 2 dots you want. And we get our other line. How we doing? Is that making sense? And now, so be really careful as you graph those lines. You have to get them right on. If you're off at all, if your dots are not perfectly on where they're supposed to be, it will not give you credit. You got to be exactly and perfectly on the mark. Okay, now the overall answer to the question is where the 2 lines intersect. And that's right here. Intersect right here. What's the coordinates of that point? Over 1, up 4. Right? That dot right there where they intersect is over 1, up 4. Parentheses around it. Over, you got to select this box right here. over 1 up 4. So that's the answer to this question. So we graph both the lines and we find where the two lines intersect, and where they intersect is the answer to the whole system, to both equations at the same time. Meaning, what does that mean? That means if you, this is X and this is Y, right? If you plugged in 1 for X in both places, and you plugged in 4 for Y, you would get true statements out of both of them. See, this one would be 4 equals 2 times 1 plus 2. 4 equals 2 plus 2. 4 equals 4. That's true. And how about the other one? 1 equals 1. There's only a place to plug in X. See how 1, 4 makes both equations true? That's because that point is on both lines. The point over 1 up 4 is on both lines. If you're on a line, you make its equation true, right? All the points that are on this line make its equation true. And all the points on this other line make its equation true. So any point that's on both lines makes both equations true. That's why we call that the solution to both of them, or the solution to the whole system. So there we go. Again, I caution you, make sure these dots are exactly on the mark. If this is off just a little bit to the right or up or down or left, or this other one, you know, it'll mess you up. Make sure they're exactly right on. There we go.